All right, so this video, we're gonna use perpendicular lines. Discussion about that, it's problems at the end of the video. But it's gonna be a kind of a stepping stone into what's really going on in the linear process. That's at the heart of this video, I hope. Haven't made one quite like this before, so we'll see where it takes us. Let's establish one thing about perpendicular lines, and then I want to get into the linear process, what's going on. All right, so I just used the marker and went 3 units horizontally, which is a change in X, and 1 unit vertically, change in Y. And that's what we refer to as rise over run, 1/3. And I want to get into this deeply, all right, in just a moment. But measuring the perpendicular, I just put the marker here and tried to guess what was perpendicular. All right, and we can see that 1, 2, 3. The change in Y, -3, right? Because I moved from left to right. If I move to the right, I gotta come down 1. So that's the perpendicular. All right, there's our negative reciprocal. One positive, the other's negative. And this rise becomes the run in the perpendicular, and this run becomes the negative rise in that perpendicular. All right, so that's just mechanics. All right, but let's take a look at a linear function written in standard form. Let me make sure that you can see everything. So let's push that back, this out of the way. Should have had that done before. All right, let's get the science card and let's see if this is centered. And yes, pretty good. All right, so this is called standard form. Every linear function can be converted into that form. So what I'm going to talk about is taking place in slope-intercept, point slope. I like to use the ax minus h plus k form, which isn't in the textbooks generally. It's generally not written that way. I think that's the best way to write the equation of a line. But in all those forms, the process I'm going to talk about takes place. So let's try to generate that process. And then let's try to generalize what's going on. All right, so first off, I've got two numbers subtract to be 0. Okay, so if this number is 10, I guess this one has to be 10 as well. And so we'll just collect some data for x's and y's. And 10 minus 10 appears to be 0. And if this becomes 15, then it looks like this has to be 15 as well. And we can start generating some numbers like that's 20, then that's got to be 20. And we can start to see a change of 5 here, a change of 5 there. Could have been 11. 11 minus 11 is 0. Could have been, but it appears to be a 5 to 5 or a 1 to 1 rate of change. Okay. Well, what's another way of writing x minus y equals 0? Well, I could put the minus y on the other side, and it becomes positive y, and it looks like my x's equal my y's. And I do believe we can see that here with whatever we pick. But if this box gets bigger, sure seems like this one has to get bigger too, in order to maintain truth, justice, and wherever you're from that way. If you have truth and justice in your country. Let's hope so. Let's keep working towards it. But what happens to this picture if all of a sudden I make this a 2y? Well, I think I actually only need half of what I had before. Let's start again. Start with 10. This is 10. I think I need the number 5 in this box for my y. Okay, remember this box is representing the y, and this box is representing the x quantities. So I think if I double the y's and I do subtraction, I think I'm getting 0. So let's change our number now to 20. Yeah. Well, this has to be 20, so I think this has to be 10.
Let's go to 30. Looks like this has to be 15. Looks like a ratio of change here. Looks like a 5 to 10 ratio of change. What is the 5? That's the change in y. What is the 10? That's the change in x. Seems to me that if I give you 10, this has to be 5. So I would have to get rid of that 10 and bring in the 5. Seems like if I give you 20, I start with 20. Or 30, I start with 30. Sure looks like the change isn't 30 on the other side. No, looks like the change is 15. Seems like there's a pattern here. Seems like if I give you an x value, you're changing it. You're changing that x to some y. Yeah, in other words, not quite sure I wanted to put it that way. I mean, it's a conversion process, right? X to Y. So, I wonder what that conversion is here. It seems like it's 1 to 2. Oh, I guess I could solve this equation for Y. I could move the negative 2y to the other side, and then I could divide x by 2, which is the same thing as multiplying x by a half. And I do believe over here, if I gave you 30 and we wanted 15, not 30. Well, that does appear to be an x value. And it does appear that I'm multiplying it by a half. Which I suppose means that if I went from 10 to 20, I went up 10, and from 5 to 10, I went up 5. That appears to be a 1 to 2 ratio of change. So it sure seems to me that these multipliers are really all about ratios of change. And if one number gets bigger and you're equaling a constant, the other side has to get bigger. And if we're adding, if one number gets bigger, then the other one has to get smaller in a certain ratio. All right. It gets a little more complicated, I think, if we put a 3 in front of the x. Let's make it a 4. Let's make it a 4, because I think I can work with even numbers better. So let's say that x is 10. All right, so 10, this has to be 10 minus 2 times y has to be 10. But this time, let's add them. Let's add them up. Okay, so if x is 10, let's just get some data here. And then let's look at the data. So if x is 10 plus 2 times something, and we want to get 0 out of that. Well, I think this has to be minus 5. And let's make this 20. So we can, oh, wait a minute, I'm sorry. I got mixed up here myself, first time here. I'm multiplying by 4, right? So let's pick 10 here. I've got to get a 4 out here. So that's now 40. I've got to figure out doubling what gets me 40. Doubling 20, right? Gets me 40, but I gotta make it add up to a count. I think it has to be minus 20. 40 minus 40, yeah. So if I started with 10, my y value is minus 20 in this equation. Well, let's try another number. Let's make this 20. Well, that's 80. Well, I guess this one has to be minus 40 over here for y, because 80 minus 80 is 0. So I went to 20, and this one went to minus 40. Well, let's make this, let's go up to 30 here, right? 20, 10, 20, 30, got a nice pattern here. Well, that's 120. I think this needs to be minus 60. And it sure seems to me that what am I doing to my x's? It seems like I'm multiplying by negative 2 to 1. Well, this goes up 20, and that's the change in x. And over here, this goes down. This goes up 10, excuse me. 10 to 20 goes up 10, and this goes down 20. So 10 units of change. If we get rid of 10 units of change and I bring that in, looks like a multiplication of -2. Looks like a -2 to 1. Looks like a -2 to 1 ratio of change here. Well, let's solve this equation for y. Let's see what we get. Well, I can keep the 2y on this side. Looks like positive 4x becomes minus 4x. And it looks like I'm dividing by -4. Okay, and that's gonna get me, I'm sorry, I gotta isolate the y, not doing a great job here. I gotta divide by 2, minus 2x, which is really -2 over. Oh, geez, that ratio of change seems to show up when we solve the equation for y. I wonder what's perpendicular to -2 over 1. I think 1 over 2 perhaps. All right, so it's time to do 4 problems. And we will hopefully make one last comment after the 4 problem practice. Because the same process of ratio of change actually occurs in implicit differentiation in a problem like this. X squared plus y squared equals 25. You don't have to have, I mean, if you're going into STEM or trying to get up the ladder and really understand what's going on, stick around till the end of the video and I'll crunch those numbers for you. Right now, we're going back to Algebra 1 and Algebra 2, and Algebra 2 could be called, let's close the gaps from Algebra 1. So here we go. We'll do 4 problems. Problem 1, 5x minus 3y equals 107. Constants don't matter, right? It's really 5x minus 3y. It doesn't matter what the number is over here, right? This is going to be the ratio of change you're looking for. And let's have it go through the coordinate 4, 7. All right, so what's the ratio of change? Well, we have to look at 5x and we have to look at 3y. We have to look at the interplay. So 5/3 x equals y. That's the original slope. I need the perpendicular slope. Rise over run switch. If this is going up, this is coming down through 4, 7. And we have our ratio of change now. As x's change, as these x's change, I gotta take -3/5 of that change because that's what's going to show up in the y column. Let's try another one, and I'll do the constant this time just to show you it has no bearing. Let's do 7x plus 2y equals 35. I'll put it in y equals mx plus b, which I can't stand. I mean, it comes into play later on. Yes, it does. But I don't want a linear mindset in here. All right, so 2y equals minus 7x plus 35. Y equals minus 7 halves x plus 35 halves. Where's the slope? It isn't over here. It's the ratio of change is right there. What's the perpendicular ratio of change? 2/7. Right? The rise and the run switch. If that's negative, this is positive. Let's have it go through minus 899. Then you write x plus 899. All right, that's the second problem. Let's try another one. Let's look at 4x minus 5y equals 97. We don't care about that. 4x equals 5y. It looks like 4/5 x equals y. 4/5 is our ratio of change. Therefore, our new ratio of change is minus 5/4. And let's have it go through the quantity AB. And that becomes x minus a plus b with the slope we want. And let's go cat mouse on the next one. Let's have it go through the point cat mouse. And then let's look at 7x plus 9y equals pi. So therefore, 9y equals 7x. We don't care about pi unless it's apple, I like apple pie. Getting y alone is 7/9. And there's our, pi divided by 9, whatever. But we're gonna go cat mouse here. There's the original slope, so minus 9/7. If that one's going up, the perpendicular is going down. And we want it to go through cat mouse, so x minus cat. If you give me a cat, I'll catch you a mouse. Well, that's terrible fun. Better change that. Let's change that to hi there. How about this? Get you that. Oh, I like that one. So let's do x minus this. If I put this in here, you're gonna get that. Boy, I like that one. All right, so that's it for your work, perpendiculars. I'll give you a little quiz, and one of them, I might as well tell you this one. I think it's gonna be 7x plus 9y equals pi. So 7x plus 9y equals pi. And you're gonna do the work, and it's gonna go through this, that, and I'm gonna find out if you watch the video, because a lot of people aren't. And I don't know where you're gonna get your practice. 70 minutes a day, we're trying to close a lot of gaps. Okay, so let's just look at the x squared plus y squared equals 25, which in algebra 2 you're gonna be seeing soon. Unfortunately, not as soon as I'd like, because you need to understand the Pythagorean video that a lot of people didn't watch. So we're already behind there, but 3 times 3 is 9, and 16 adds up to 25. If you square 3.001, you get a slightly bigger area, right? You get a bigger area, and it increases by 0.06. And if this is going to add up to 25, then this area has to actually come down, and it comes down in a ratio of, if you square 4, you get 16.008, and there's some other decimals, but they're so small we're ignoring them. And if you multiply that by minus 3/4, you actually balance off that change, and it's a ratio of change. And that's what you're going to be studying when you look at implicit differentiation. Right, you got your 2x dx and 2y dy equals 0. If you're seeing this number change, please see me after class. We'll help you out, talk a little bit. Still 25, I don't think it's changing. Don't think there's any variability in that number. Okay. All right, so that was an attempt at actually trying to explain what's going on with a linear function. We use the perpendiculars as our examples. Maybe it moves the needle a little bit. I know that the best thing I ever heard from one of my mentors, because I've learned math as an adult, Della said, when I was coming up with some gimmicks, trying to explain some gimmicks for, who knows, I think it was logarithms. I'm not sure I understood logarithms myself. And he looked at me after I said something that was pretty ridiculous. He went, Jim, tell him what it is, not what it isn't. So that's what I'm trying to do in the video, is trying to explain geometrically, numerically, and otherwise, analytically, what's going on graphically, to the best of my ability. And I'm hoping it helps, but you got to do this in math. There's no way around it. You got to think about the things that are being presented. And if it's just, turning it on and getting an assignment done, you go, okay, I played it for 6 minutes. It's not going to get it done. You got to work and you got to think. All right, good luck with that process. I'll try to keep reminding you of it.